Welcome to Omega Open course. In this video we will discuss about pseudo force. We will be discussing what a pseudo force is, when it is applied, what is its magnitude, and is it absolutely necessary to solve a problem. In order to understand what a pseudo force is, let us consider this situation. There is a railroad cart standing on a railway track. There are two observers. One is standing on the railroad cart while the other one is standing on the ground. Now suppose the cart starts to accelerate towards right. For the observer on the ground, the situation is very simple. The cart has started accelerating, so the cart along with the observer on the cart are moving ahead with some acceleration. The motion of the cart has no effect on the rocks scattered on the ground. This observation is in accordance with Newton's laws of motion. There is no horizontal force acting on the rocks, so the rocks are at rest. But for the observer on the cart, the situation is more complicated. Since he is standing on the cart, to him the cart will appear to be at rest. But the rocks on the ground will appear to be moving backward with the same acceleration as the acceleration of the cart. For him, the Newton's laws of motion is being violated. The rocks are moving without any horizontal force. Alternatively, we can say that to the observer on the cart, it will appear as if there are some forces acting on the rocks in backward direction, and because of these forces, everything is accelerating in backward direction. Of course, there is no force. Rocks appear to move only because the observer himself is accelerating. But in the frame attached to the cart, there appears to be a force acting in opposite direction on all the objects. This force is called pseudo force. Pseudo means false. Thus, it is a false force. It does not really exist. It appears only when our frame of reference is accelerating. In other words, whenever we are analyzing a situation from a frame that is accelerating, all bodies in that frame will experience an extra force, the pseudo force. When your frame of reference is accelerating in forward direction, all the objects will appear to be accelerating in backward direction. Therefore, the direction of pseudo force is always in direction opposite to the direction of acceleration of the frame. Also, if the frame is accelerating with acceleration a, all the objects at rest will appear to be moving with acceleration a in backward direction. So the apparent force must be equal to the product of mass of the object and acceleration of the frame. Then only it will be able to satisfy Newton's second law of motion. Hence, the magnitude of pseudo force is always equal to mass of the object into acceleration of the frame. To summarize, pseudo force does not really exist. It appears only when our frame of reference is accelerating. Its direction is always opposite to the direction of acceleration of the frame, and its magnitude is always equal to the product of mass of the object and acceleration of the frame. Pseudo force is not absolutely necessary to solve a question. Every question that requires pseudo force to solve can be solved without using pseudo force also. But in some cases, solving using pseudo force is more efficient. The frame which is not accelerating is called inertial frame, and the accelerating frame is usually called non-inertial frame. In the following examples, we will discuss situations where pseudo force may be used to solve the question, and we will also discuss how to solve those questions without applying pseudo force. Consider a block kept in a box. Suppose the box is pulled up with acceleration a. We have to calculate the normal reaction acting on the block. We can solve this question in the reference frame of the ground or in the frame of the box itself. If we look at the box from the ground, the box appears to be moving up with acceleration a and the block moves along with it. If we draw the free body diagram of the block, the gravitational force of mg acts in vertically downward direction. Normal contact force from the box acts in vertically upward direction. In our frame, the block is accelerating with acceleration a, so the net force in upward direction must be equal to m into a. Thus, n minus mg must be equal to ma. Solving this equation, we can find the value of n. Now let us look at the block with respect to the box. As you can see, in this case, the block appears to be at rest. Now let us draw the free body diagram of the block in this frame. Gravitational force of mg acts in downward direction and normal contact force in upward direction. In our frame, the block is at rest, but since our frame is accelerating, there must act a pseudo force. Since the acceleration of the frame is in upward direction, the direction of pseudo force must be downward. Also, as the magnitude of acceleration of the frame is a and the mass of the block is m, the magnitude of pseudo force is ma. As the block is at rest, net force on it must be 0, or the upward force must be equal to downward force, or n must be equal to mg plus ma. Now let us compare these two situations. When we are looking at the block from the ground, our frame of reference is inertial, hence there is no pseudo force. But in our frame, the block is accelerating and hence net force must act on the block. When we look at the block with respect to the box, the frame is non-inertial and hence pseudo force must act on it. But in our frame, the block is at rest and hence net force on the block must be 0. So you can see it depends on you what frame of reference you choose to solve a problem. If the frame you selected is inertial or not accelerating, there will be no pseudo force. But if you choose to solve a problem in accelerating or non-inertial frame, there will be pseudo force. Motion of the object will be different in both the cases. Let us look at another example. Suppose a bob is suspended to the ceiling of a truck through a string. The truck starts accelerating and we have to calculate the tension in the string and the direction in which the string tilts. We can choose to solve this question either with respect to the road or with respect to the truck itself. If we look at the system with respect to the road, our frame is inertial and hence no pseudo force will act. But the bob will move with the acceleration same as the acceleration of the truck. Let us assume the thread makes an angle theta with the vertical. Now in the free body diagram of the bob, gravitational force of mg will act in downward direction and tension in the string will act along the string. The bob is accelerating in forward direction with acceleration a. The vertical component of the tension must be equal to gravity, hence t cos theta must be equal to mg. Net force in horizontal direction must be equal to mass into acceleration, therefore t sin theta must be equal to ma. Solving these equations, we can find the value of tension and theta. Now let us look at the system with respect to the truck. As you can see, in this case the bob appears to be at rest, hence net force on it must be 0. But as our frame is accelerated, a pseudo force of magnitude ma will act on it in opposite direction. Gravity and tension will remain same as in previous case. Since the bob is at rest, net force on it must be 0, hence vertical component of tension must be equal to gravitational force or t cos theta must be equal to mg. Similarly, horizontal component of tension must balance the pseudo force, hence t sin theta must be equal to ma. As you can see, when we choose inertial frame, the bob has acceleration. But when we choose an accelerating frame, the bob comes to rest and a pseudo force starts acting on it. The question can be solved in both the frames and the equations we get in both the cases are almost the same. But there are situations where selecting a non-inertial frame might simplify the situation greatly and reduce the effort in solving the question. For example, consider this situation. A block is kept on a frictionless triangular wedge kept on a frictionless surface. Also, assume the inclination of the wedge to be theta. When the system is released, the block moves down the wedge and the wedge slides backward. Suppose we have to find the acceleration of the block and the wedge. If we try to solve the question with respect to the floor, the situation is complicated. While we do know that the wedge is moving in horizontal direction, we do not actually know in what direction the block is moving. As you can see, when the block moves down, the wedge slides backward and the direction in which the block is moving becomes different from the direction of the incline. Thus, in this frame, there are three unknowns: the acceleration of the block, the acceleration of the wedge, and the direction of the acceleration of the block. But if we look at the block with respect to the wedge, the block moves along the slope of the wedge. Hence, its direction must be same as the inclination of the wedge. Thus, the direction of its acceleration is at an angle theta with the horizontal. So there are only two unknowns, the acceleration of the wedge and the acceleration of the block. But since our frame is accelerated, an additional force, the pseudo force, will act on the block in direction opposite to the direction of acceleration of the wedge. Thus, in the free body diagram of the block, there will be gravity in downward direction, normal perpendicular to the wedge, and pseudo force towards the right. The direction of the acceleration of the block will be along the inclination of the wedge. Since we know the direction of motion of wedge, we do not need to analyze it in non-inertial frame. In its free body diagram, the only force having horizontal component is normal, and that component is causing its acceleration. Now you can write equations and solve them to find the accelerations. To conclude, whether pseudo force will act in a situation or not depends on your choice of the reference frame. If your frame of reference is inertial or having no acceleration, there will be no pseudo force. But if you choose a frame which is accelerating, then a pseudo force will act on all the objects in the frame in the direction opposite to the direction of the acceleration of the frame. The magnitude of pseudo force is always mass of the object into acceleration of the frame. Every question can be solved in inertial frame, that is without using pseudo force. However, there are some situations where using non-inertial frame simplifies the motion greatly, and using pseudo force in those cases may reduce the effort in problem solving. I hope you find this video helpful in understanding pseudo force and its use. You may like to watch our other videos dealing with concepts and tools of physics. Like and share the video to help other students find us. Subscribe the channel, like our Facebook page and follow us on Twitter for latest updates. Thank you for watching.